Neutron stars birth a kilonova. Feeling up for a fireworks show of galactic proportions, Tomo sapiens? Then aren't you in for a treat? Millions of light years from the Milky Way, inside the HYDRA constellation is an elliptical galaxy. It's here astronomers believe they detected both light and gravity from a kilonova event. That's cool, Tomo, but what the Kenobi are they? First detected in 2013, a kilonova is a class of supernova explosion resulting from two colliding neutron stars. The Space Telescope Science Institute says each neutron in this case was no wider than Washington, D.C. Typically, they're between 6 and 12 miles in diameter. The Institute added that the stars in question weighed between 10% and 60% more than our Sun. That's 4.18 nonillion pounds, 4.18 followed by 30 zeros, multiplied by 1.1 and 1.6 times respectively. It's the collision of two of these ultra-compact densities that astronomers believe emitted light and gravity strong enough to be observed on Earth. And that's a big deal, because it's the first time gravity and light have been spotted coming from the same cosmic event. What followed the kilonova is unknown, but NASA astrophysicist Eleonora Troja speculates the cosmic explosion may have formed a black hole. And inside that, Tomo sapiens, is what's generally referred to as the point of no return, a place beyond reality. How cool is space? Better call the alien welcome party, for now. This is KIC 8762852, aka Tabby Star. Since October 2015, it had space buffs lit with speculation that it's an alien superscience. Except it's not. Dyson spheres are theoretical cosmic megastructures. They envelop a planet with energy-absorbing technology which directs power to a central location. Some astronomers previously theorized the dimming of Tabby Star was caused by this. This star is located 1,280 light-years from Earth. New research using data from NASA's Spitzer and Swift space telescopes suggests the dimming is actually due to a dust cloud orbiting the star. Known as circumstellar dust, NASA says these particles are not small enough to fly into space, but also not big enough to block light all the time on all wavelengths. But they can't be absolutely positively sure, so we're still holding out for the Death Star.
Ever wonder how the Earth was formed? Two new studies published in the journal Nature have shed some light on how Earth's strange chemical makeup came to be. Our solar system began some 4.6 billion years ago as a swirling disk of gas and dust. This all came together to form rocks, planetesimals, and eventually full-size planets. But scientists have long been puzzled by the difference in composition between Earth and the meteorites believed to have formed it. The answer, it seems, lies in Earth's explosive history. Early Earth often collided with other planetary bodies, with the impact generating enough heat to turn rocks into either magma or hot vapor. One study estimates the planet lost 40% of its mass from this process. A second study combined Earth rock with volatile elements such as gold, silver, and zinc oxide and heated it to 1,300 degrees Celsius. After cooling the rock, they discovered that the volatile elements had evaporated. This same vapor loss was found in samples from Mars and the asteroid Vesta, suggesting that the phenomenon occurs in similar-sized bodies. The two studies may have solved some riddles about the Earth's composition, but many mysteries remain.
Scientists may have found Planet 10. U.S. scientists have found evidence supporting the unseen Planet 10, which is much closer than the previously reported Planet 9, a planet that has not yet fully been proven to exist. The Kuiper Belt is a disc-shaped region in outer space that contains icy bodies, space rocks, and dwarf planets such as Pluto. It is understood that Kuiper Belt objects orbit the Sun with an orbital tilt, but those some 50 astronomical units away from the Sun should not. However, researchers have discovered that a group of Kuiper Belt objects located between 50 to 80 astronomical units from the Sun are tilted away from the invariable plane by 8 degrees, suggesting a large object with sufficient gravitational influence is causing this warp. Experts believe the unseen object is possibly as massive as Mars and is roughly 60 astronomical units from the Sun on an orbit tilted by 8 degrees to the average plane of known planets. Planet 10 is theoretically much closer to Earth than Planet 9, the hypothetical planet discovered in 2016. Planet 9 is predicted to be the equivalent of about 10 Earth masses, and located between 500 to 700 astronomical units from the Sun. Saturn probe enters grand finale. NASA's Cassini spacecraft has begun the final stage of its mission after nearly 20 years traveling in space. The Cassini spacecraft entered its grand finale orbits between Saturn's cloud tops and the planet's rings on April 26, 2017. According to NASA, Cassini survived its first dive between Saturn and its innermost rings, sending back never-before-seen images of the planet's atmosphere, including this hurricane. During the dives, Cassini will measure ice and other content in Saturn's rings and take measurements from the planet's rocky core. Cassini will enter its final orbit on September 15th, in which it is expected to destroy itself by flying directly into Saturn's atmosphere. The Cassini spacecraft was launched in October 1997 from Cape Canaveral Air Force Station in Florida. It traveled 2.2 billion miles to reach Saturn.
NASA investigates the effects of space radiation on the body. One of NASA's biggest challenges in designing a mission to Mars is how to protect astronauts on the long space journey. NASA's Human Research Program is currently researching how space radiation affects the human body. Space radiation has enough energy to violently collide with nuclei that make up spacecraft shielding and human tissue. The collisions cause both the shielding nuclei and space radiation to break up into several different types of new particles, known as secondary radiation. NASA is currently focusing on the effects of galactic cosmic rays on the human body. GCRs that come from supernovas outside the solar system are the most harmful to the body. One of the main difficulties is that it's hard to simulate space radiation on Earth. Lab doses of radiation could be stronger and given for a shorter time than actual conditions in space.
The heliosphere, NASA's Voyagers beyond the solar system. NASA's twin Voyagers, both launched 4 decades ago this year, have traveled to the edges of and beyond our solar system, and through the heliosphere. That's basically a giant solar space bubble, protecting our solar system from deadly cosmic rays. NASA's Voyager 2 launched 40 years ago on August 20th, 1977. It's currently in a region of space known as the heliosheath. This forms part of the heliosphere. That's a giant multi-tiered magnetic bubble originating from the Sun in which our solar system resides. The heliosheath is a turbulent region of space that has 700 km/h solar winds. The prefix helios comes from the Greek Titan god of the Sun. The heliosheath is past the termination shock, an outer limit of our solar system where these winds are impacted by interstellar winds. Outside the heliosheath is the heliopause, an area that balances both winds, sending them back down to the tail of the heliosphere. And beyond that is interstellar space, the space between stars. This is where Voyager 1 currently is. They've got enough power to last until 2020, after which NASA says they'll be destined to drift through the Milky Way for probably all of time.